Good morning. Let's start the lesson. Soil and its soil and its constituents. Introduction of soil. Soils are one of the Earth's essential and natural resources, yet they are often taken for granted. Most people do not realize that soils are a living, breathing world supporting nearly all terrestrial life. Soils and the functions they play within an ecosystem vary greatly from one location to another as a result of many factors, including differences in climate, the animal and plant life living on them, the soil's parent material, the position of the soil on the landscape, and the age of the soil. Soil is a non renewable, dynamic natural resource that is essential to life. Water movement, water quality, land use, and vegetation productivity all have relationships with soil. Soil is one of the three major natural resources alongside air and water. It is one of the marvelous products of nature and without which there will be no life. Soil is made up of three main components: minerals that come from rocks below or nearby, organic matter, which is the remains of plants and animals that use the soil, and the living. It is a biologically active porous medium that is present on the uppermost layer of the Earth's crust, formed by weathering processes under various influences. Soil acts as a substratum for life on Earth that serves as a reservoir of water and nutrients, a medium for the breakdown of organic materials, and as a participant of various biogeochemical cycles. The soil is any particular area evolves through a series of weathering processes that are influenced by biological, topographical, climatic, and geographical factors. As studies on agriculture and geology have increased, the soil is now considered a complex, dynamic biogeochemical system that is vital to the life cycles of various land vegetation and soil inhabiting organisms. Soil is one of the most important elements of an ecosystem as it contains both biotic and abiotic components. Soil and agriculture. Agricultural, agricultural viability depends upon a health soil. Agriculture Samagra Health Good. A healthy soil is obtained through knowledge of the soil and the application of appropriate management particles. Poor management particles can lead to soil degradation, which can reduce productivity. Soil is not a renewable source. Soil is not a renewable source. The loss of 1 mm of topsoil can take 3000 years to replace. Soil has a number of functions important for agricultural production, these being a medium for plant growth, supplying and retaining nutrients, oxygen, and water, a medium for the decomposition of crop and pasture residues, an anchor for plants, a medium that should support machinery and animal traffic under most soil conditions without degradation. Soil is essentially made up of four main fractions, but the fractions vary greatly in arrangement and form. Hence, soils can be physically and chemically quite different. Understanding why soil can be so varied and how different soils require different management is important for an effective farming enterprise. What is the soil moisture? Soil moisture is the volumetric water content of a soil held within the spaces, the soil particles or soil aggregates. Soil moisture is of two types. Surface soil moisture is the water present on the upper layer of soil, whereas root zone moisture is the water available to plants generally present within the soil. The moisture of the soil is considered an indicator of the quality of soil and the fertility of the soil. What is the soil matrix? Soil matrix refers to all the solid particles found in a soil that include the soil particles, organic matter, and other inorganic materials. The soil particles might either be sand, silt, or clay, the composition of which might differ from one type of soil to another and the location. Organic matter found in the soil matrix is humus, which is the final stage of degradation of dead plants and animals. Humus might even form organic colloids with water and other inorganic substances. The soil matrix determines various physical and chemical properties of soil like water retention capacity, nutrient content, and pH. Soil formation process and factors affecting soil genesis. Describe the process and factors of soil genesis. Soil formation is the consequence of a combination of biological, physical, and chemical processes. Soil should ideally contain 50% solid material and 50% pore space. About one half of the pore space should contain water, while the other half should contain air. The organic component of soil serves as a cementing agent, returns nutrients to the component of soil, returns nutrients to the plant, allows soil to store moisture, makes soil tillable for farming, and provides again about one half of the pore space should contain water, while the other half should contain air. The organic component of soil serves as a cementing agent, returns nutrients to the plant, allows soil to store moisture, makes soil tillable for farming, and provides energy for soil microorganisms. Most soil microorganisms like bacteria, algae, and fungi are dormant in dry soil but become active once moisture is available. Soil distribution is not homogeneous because its formation results in the production of layers. The vertical section of the layers of soil is called the soil profile. Within the soil profile, soil scientists define zones called horizons, a soil layer with distinct physical and chemical properties that differ from those of other layers. Five factors account for soil formation. They are parent material, climate, topography, biological factors, and time. Parent material. The organic and inorganic material in which soils form is the parent material. Mineral soils form directly from the weathering of bedrock, the soil rock that lies beneath the soil. Therefore, they have a similar composition to the original rock. Other soils form in materials that came from elsewhere, such as sand and glacial drift. Materials located in the depth of the soil are relatively unchanged compared with the deposited material. Sediments in rivers may have different characteristics depending on whether the stream moves quickly or slowly. A fast moving river could have sediments of rocks and sand, whereas a slow moving river could have fine textured materials such as clay. Climate. Temperature, moisture, and wind cause different patterns of weathering which affect soil characteristics. The presence of moisture and nutrients from weathering will also promote biological activity, a key component of a quality soil. Topography. Regional surface features, familiarly called the lay of the land, can have a major influence on the characteristics and fertility of a soil. Topography affects water runoff, which strips away parent material and affects plant growth. Steep soils are more prone to erosion and may be thinner than soils that are relatively flat or level. Biological factors. The presence of living organisms greatly affects soil formation and structure. Animals and microorganisms can produce pores and surfaces. Plant roots can penetrate into surfaces to produce more fragmentation. Plant secretions promote the development of microorganisms around the root in an area known as the rhizosphere. Additionally, leaves and other material that fall from the plants decompose and contribute to soil composition. Time. Time is an important factor in soil formation because soils develop over long periods. Soil formation is a dynamic process. Materials are deposited over time, decompose, and transform into other materials that can be used by living organisms or deposited onto the surface of the soil. Humus. Humus is the soil organic matter. It is a cheap source of return of minerals to the soil. It has also much of water holding capacity. It can hold minerals as ions by absorption and binds clay particles into aggregates. It makes clay soils porous, thus increasing aeration of soil and also cause easy percolation of water in the soil. Soil composition. Air 25%, water 25%, mineral particles 45%, organic matter 5%. Soil composition is an important aspect of nutrient management, while soil minerals and organic matter hold and store nutrients. Soil water is what readily provides nutrients for plant uptake. Soil air too plays an integral role since many of the microorganisms that live in the soil need air to undergo the biological processes that release additional nutrients into the soil. Soil is composed of various factors like air, water, minerals, and different living and non-living organic compounds. The entire composition of soil can be classified as biotic and abiotic components. The abiotic component includes the non-living things of soil, while the biotic component includes the you disturbing me. The entire composition of a soil can be classified as biotic and abiotic components. The abiotic component includes the non-living things of a soil, while the biotic component includes the living organisms. In general, the abiotic component of the soil accounts for about 40 to 45% of the soil volume, followed by air and water that occupy 25% each, with 5% covered by living things. The exact composition of the soil, however, might vary from place to place with the existing rocks of the area and the climate. Other factors like the quantity of vegetation, soil compaction, and water retention capacity also influences the composition of the soil of a particular area. The inorganic part of the soil is composed of rocks that are slowly broken down into smaller particles that might vary in size. The organic component of a soil is called the humus, which is made up of living organisms like insects or microorganisms, dead or alive, and dead animals and plants in varying stages of decay. Properties characteristics of a soil. The properties of a soil are determined by the composition of the soil depending on different amounts of biotic and abiotic components. The combinations of these components determine the physical and chemical properties of a soil. Physical properties. The physical properties of a soil are the result of soil parent materials being acted upon by climatic factors such as rainfall and temperature, and being affected by relief, slope and direction or aspect, and by vegetation with time. A change in any one of these soil forming factors usually results in a difference in the physical properties of the resulting soil. The important physical properties of a soil are described below. First one, soil texture. Texture refers to the relative proportions of particles of various sizes, such as sand, slate, and clay in the soil. The properties of the separates in classes commonly used in describing soils are given in the textural triangle figure below. In using the diagram, the points corresponds to the percentage of slate and clay present in the soil under consideration are located on the silt and clay lines respectively. Lines are then projected inward parallel in the first case to the clay side of the triangle and in the second case parallel to the sand side. The name of the compartment in which two lines intersect in the class name of the soil in question. For example, a soil containing 50% clay, 20% slate, and 65% sand is a sandy loam, and a soil containing equal amounts of sand, silt, and clay is a clay loam. Textural triangle. Soil texture refers to the size of the soil presents size of the soil texture refers to the size of the soil particles, that is depending on the relative proportions of mineral components like sand, silt, and clay. Soil texture is further influenced by soil porosity, infiltration, and water retention capacity. The texture of soil differs with soil type. Sandy soil feels gritty, silt feels smooth, and clay is sticky and moldable. Soil texture. The term texture is used in reference to the size of individual soil particles, but when the arrangement of the particles is considered, the term structure is used. Structure refers to the aggregation of primary soil. particles, sand, clay, and silt into compound particles or clusters of primary particles which are separated by the adjoining aggregates by surfaces of weakness. The textural components of soil, including sand, silt, and clay, might result in aggregates as a result of their clumping. The aggregates further clump together to form beds, PEDS beds. Information on the structure of soil gives information on the soil texture, matter content, and biological activity. Soil structure is influenced by physical processes that might be improved or destroyed by the choice of farming particles. Soil density. The average soil particle density ranges from 2.60 to 2.75 grams per centimeter cube, which usually remains unchanged for a given soil. The soil particle density is lower for soils with high organic matter content and higher for soil with higher mineral content. Soil particle density is different from soil bulk density, which is always less than soil particle density. Soil density usually depends on the soil texture and structure and the composition of the soil. Soil porosity. Soil porosity is defined by the number of pores present within the soil. The porosity of soil is determined by the movement of air and water within the soil. Healthy soils usually have more number of pores between and within soil aggregates, whereas poor quality soils have few pores or cracks. Soil porosity is influenced by soil texture and structure. The pore size in soil affects the ability of plants and organisms to access water, oxygen, and other gases and minerals. Soil consistency. Soil consistency refers to the ability of the soil to stick to itself or other objects and to resist deformation